Hello everyone. We have been learning about similar triangles in our past 3 videos, and our ultimate aim is to find out the postulates of similarity, the axioms of similarity. So, in order to do that, we'll have to know something called the converse of a statement. In case you do not know what converse is, just listen to the statement which I am going to make now. If a person, if this person has a viral infection, he has a viral infection, it it means that he runs a high temperature, he has fever. So, this is a statement which I am making. If a person has viral infection, he runs a high temperature. Now, what is the converse of this statement? Or is the other way round true? If a person has high temperature, does it mean that he has viral infection? And this is called the converse of this statement. The converse is, if a person has high temperature, then he has a viral infection. Now, to understand this better, let us call this situation as A. A person having viral infection as A. It implies that he has a high temperature, so this is B. So, if A implies B, then B implying A is called the converse of the statement A implies B. I hope you followed what converse is. If A implies B, then the converse is B implying A, right? So, knowing what converse is, let's proceed to this theorem which we learnt in our second video. I'll just recap it a little. Consider any triangle, sorry, this is not coming out well, yeah. So, let this be a triangle and let us draw a line parallel to one of its sides. So, let this be a line which is parallel to one of its sides. So, the triangle is ABC and we have drawn DE in such a way that it is parallel to BC. Then the line divides both the sides in the same ratio. AD by DB is equal to AE by AC. We worked on this in the second video and this is called the Basic Proportionality Theorem. Now, in this video, we are going to do the converse. We are going to see whether the converse of this theorem holds true. So, what is the converse of this theorem? Suppose this was not parallel. Let me erase this sign. Suppose these two were not parallel to one another. Still, if we knew that AD by dB is equal to AE by AC. That is, we were aware of a line DE dividing AB and AC in this ratio. Then, can we say that DE is parallel to BC? So, if AD by dB is equal to AE by AC, then DE is parallel to BC. Can we say this? This is the converse. The theorem was that DE was given parallel to BC and we proved that it divides the two sides in this ratio. Now, this is what we are in this video we are going to prove. If AD by DB is equal to AE by AC, then DE is parallel to BC. So, in order to prove that, if DE was not parallel to BC, then we should have a line which is parallel to BC, isn't it? So, we should have some other line parallel to BC. So, starting from D, there should be some other line which is parallel to BC. So, let us call that line as E dash, DE dash. So, we do not know this. This is a question mark for us. DE is parallel to BC is a question mark for us. But now we constructed a line DE dash parallel to BC. So, what do we infer by this theorem which we have already proved? We infer that DE dash divides this AB and AC in this ratio. AD by DB is equal to AE dash by E dash C. Right? Since we have assumed that DE dash is parallel to BC, we have this. And already this was true. AD by DB is equal to AE by AC, and now this is true. right? And look at the left hand sides. The left hand sides of both the lines, AD by DB, this is also AD by DB, are equal. So the right hand sides have to be equal, that is AE by EC has to be equal to AE dash by E dash C. We can compare these two ratios only if we have something in common. So let's try to bring something in common. Maybe we can try to bring in this whole side AC in common. So in order to do that, let me add 1 to both sides so that I get an AC in the numerator. So what happens when I add 1? I get AE plus EC by EC is equal to AE dash plus E dash C by E dash C. Now the numerator of both these ratios can be rewritten as AC, because if you look at the figure you will understand both of them add up to this line AC. So ultimately we have AC by EC is equal to AC by E dash C, or if you cross multiply, of course the result is evident, but still if you cross multiply you get AC multiplied by E dash C is equal to AC multiplied by EC. Of course we are talking about the lengths of the sides when we write AC, EC, etc. So you divide the result by AC on both sides, they get cancelled, and you would be able to say that E dash C is equal to EC. So what happens if E dash C and EC were the same? So this is EC and this is E dash C, but they are same. According to our proof, both are same. It means that E and E dash are one and the same point. They coincide. E and E dash coincide. So if DE dash is parallel to BC, it means that DE is parallel to BC. Actually, E and E dash are the same. And hence we have proved that if a line divides two sides of a triangle in the same ratio, then the line is parallel to the third side. And we already saw that if it was parallel, then it divides the two sides in the same ratio. So both are one and the same. So if you know that they are parallel, you can say that the ratios are same. Or if you know that the ratios are same, you can say that the line is parallel to one another. So both are finally one and the same. And now here we have proved the converse of the second video, the basic proportionality theorem has been proved. Thank you. I hope you followed.